Okay, today we're gonna look at our Playdate 3D experiment again. So we have right now these 4 points that go into the back and then just disappear in the background basically. And let's improve this a little bit. So for now, let's see what we have. So we have our points here, and we have a Z as well. And let's add another plane here. Maybe put this 0.5 plus. So we move this a little bit into the background, this plane, like right from the start. And let me see where we start here. We start with 1, okay. Plus Z. Let me copy this one. And now let's say this is a little bit more to the front. So then we get a little bit more of this 3D feeling already because we have 2 planes on top of each other. Yes, so yeah, I guess we can get an idea. It looks like a proper object in space if you only see the points. Let us rotate this. So we're gonna add a rotation function because later we want to rotate it with the Playdate, right? And of course I had to cheat a little bit because I looked this formula up. I don't just remember this without anything. So we need to rotate it, and I'm just going to type out the formula. Z float, and then for the angle we also are going to take float, and this is going to return float, float, float. Yeah, let's not build a new struct for this just yet. It's basically a 3D point. It's going to take in a 3D point and then rotate that 3D point. So I'm going to take that shortcut here, actually. That's nice. The angle, and then this is also the angle. Wow, whoa. Let's see if this is correct. It is correct, okay. Yeah, I guess it's a common function for rotating an object. Okay, so now what we got to do is we first have to take this 3D point. Okay, I see. So I guess it would make sense if we have a, if we have a 3D point. I'm gonna create that real quick. Let's call it, I think, point 3D x. Whoa. X float, float, and Z float. And now let's change it up a little bit. So for the projection, we can now also just take in a point, which is point 3D, and then we're just gonna map that from point X, point Z, point Y, point Z, point. I'm sorry, I probably should have done that from the beginning. But here we can take a shortcut now, right? This should work. What's the problem? Can I revive point 3D point? Right. Cool. So this works. We can just add this here. And then we have to add this. Great. Okay, so nothing lost there. But yeah, it starts rotating this. Rotate XZ, and then do the same thing. Okay, what is the problem? All right, because we need an angle. let me quickly angle float 0, angle. Did we call it angle? We called it, oh, but this is not accepting a point yet. Point 3D, and of course it then also has to return a 3D point 3D. Point. Okay. So this worked, right? XZ. And at an angle. Okay, let's make this faster. And just copy this. Here, and here. Boom, okay. And now we want to animate that angle as well. So we're gonna do something similar again, system elapsed time, and then divided by 100, just to see, okay. This, what? This wants to be a double? Oh, come on. There's no, there is. Okay, this fixes it. It looks very ugly, and I'm not sure why this is like that, but it's working. So let's just use this. Okay, so we have this. It looks interesting. It's pretty fast, and it moves to the background. I think I made a mistake with a rotation here. Let me look into that. I think I should have changed. I need to apply the angle a little bit differently. So I'm going to add a function here, translateZ, that just takes in like a DZ, I guess, to translate it. And I'm going to spit out a new 3D point. This looks correct. And now I'm going to apply this after the rotation. This is getting kind of hard to read. I need to think about how to make this easier later. But yeah, so first we rotate and then we translate. Yes, I think that is the right order of steps. That's why we're seeing this weird. You know what? Make this a little bit more swifty. translateZ by, and then just call it DZ, because I think that reads way nicer. translateZ by. Boom. Okay. So add this to all of the points. Cool. Try this again. I think it should work better. Okay. Something new that looks completely wrong. And we missed it. Oh, yeah, we applied it wrong. Yeah, this is getting really hard to read. I need to think of a way to make that better, because we need to apply this after the rotation, not before. So this is actually here. Great. Compile again. Hope this works better. Okay, it's a little bit slow. It looks a little bit not like what I imagined it would look like. Let's maybe remove the Z animation and just keep rotating it. Okay. It feels like we only have one plane, and somehow this is getting. Of course it's getting faster because we don't have a time difference. Yeah, this is getting faster. Faster, it kind of makes me dizzy. Okay, I found a very stupid mistake here. We were using this Z and not the point Z. And once we fix that, the animation works like expected. Let's quickly check. Yes, it's very slow and then gets faster because of what we do with elapsed time here. It's not super smart. But yeah, let's add the Z translation again. So it like slowly, not slowly, but it moves into the background faster and faster. Yeah, so it's rotating like that, you can see. So it already looks like a 3D object in space, but now we need to add lines. And we also need to, we basically need to add lines to make it like look good. I'm gonna remove this and I'm gonna move it a little bit more to the back. And yeah, let's see how we can improve this. Basically, it would be cool. Time offset from no. Current time milliseconds. Since Playdate reset elapsed time was called. I mean, okay, a stupid thing would be reset elapsed time and just call it every time. It's a stupid hack, but it should work. Nope. Right, because now it's always 0. Okay, let's think about how to improve this elapsed time. I guess we just... Okay, quickly, let's get the cat. Let's get the cat before we do anything else. Yeah, come here. Okay. Hey guys. Okay, let's skip the sync poll. So we can get the time, or actually I don't know what it is. System time, elapsed time, current time, milliseconds, perfect. Okay, this is a signed int, which means we will need to do... can we do this? Probably not, right? Yeah, okay. C, what was it? No, C int, no. Signed integer, no. What is this? Unsigned int, okay. Cool. And then let's just set this again every time. System current is okay. And then we just calculate difference between which we need to do before. Right, time. No, actually, system current minus time. Okay, why is this not working? Right, because this is a float. This is easy. Okay. Wait, we're not playing around with this anymore. I totally forgot. So we need to do this. Cool. We just applied it on the wrong one, I guess. Okay. Let's call this time difference. And then just reuse this, right? So instead of the elapsed time, we can just use the TD for the rotation. And then actually I was thinking we could, whoa, that is really fast. Let's just remove this because we don't need the going away part anymore. Perfect. Okay, so now we have this object in space that just keeps on rotating. Yeah, I would say let's leave it at that for today. And we move on to adding faces tomorrow to this. So it's like looks like a full cube. And then we're also gonna hook it up to the Playdate's crank.